So what we're going to do is visualize the list of best-selling pharmaceutical drugs in 2017-18 using PPTX Handler. This is a list from Wikipedia, which shows the top 16 best-selling pharmaceuticals in 2017 and 2018. And what we want to do is create a page that looks like this, a slide with some kind of a background, a PowerPoint table, and some text which is ideally automatically generated. Now, let's start with creating a template for this. You can download the template from the page. It's at learn.camera.com/guide/pptxhandler under table. And what this template has is a simple structure. It has the title itself, the text, and a table which actually doesn't really have much by way of contents. What we're really going to do is take the data that we have and put it into this table. So let's see how we can do that. First step is to take the data from Wikipedia. Well, realistically, the data is just a copy paste of this into an Excel file. So I'm just going to open Excel and paste this. So let's create a blank workbook and paste the data as it is. And we'll do a little bit of reformatting of this. And this is what the underlying data looks like. Same content, but just saved as a file called sales.csv. Now that we have the template and we have the data, let's start by creating all the rules. So we'll start by creating a file called gramex.yaml. And in this file, let's save this as gramex.yaml. And in this, we'll copy this set of rules. What this says is we're going to create an output.pptx using pptx handler using version 2 of the API. And it's going to take the template file from template.pptx in the current YAML files path, and also take the data from sales.csv and put it into a variable called sales. This by itself does nothing. And what we'll also want to do is for the output that we want to create out here, we will also need a few additional columns. So for example, growth is not available here. We have 2017 and 2018, but not the growth. So we'll have to add that. And there's also a couple of other columns that we want to add. One is a column that indicates, well, roughly the number of some text that creates the equivalent of a bar chart. That's because PowerPoint doesn't support bar charts within tables or any kind of chart within tables by itself. So what we'll do is use some character to create these extra columns. So this, and this are the three columns we're going to add from a data perspective. So for this, we will be using pandas to create these three new columns. Here's the command, but I'll tell you how we got here. Now, this says data.insert at position 3, a column named bar 2018, which contains the same data as FY 2018, the column number 2018. And then later on, we'll make some more modifications with that. But effectively, this just adds a new column called bar 2018, which is the same as FY 2018. And that's this. In other words, what we will have is bar 2018 with exactly the same contents. That's what this will have. Same as column 5 with bar 2017. So this will create a bar 2017 with exactly the same data as this. And this will create a new column, the last column called growth. And this column will have the FY 2018 by FY 2017 minus 1. In other words, FY 2018, sorry, that was FY 2018 by FY 2017 minus 1. And this expressed well. I'll just show it to you as a percentage. But this is what it's going to create. I'm not going to save this. I'm going to, in fact, undo all of the changes that we made, because these are going to get done programmatically so that if the data gets updated in exactly the original format, the data transformation will still work. So that is going to get through here. Let's just add that as a transform. So we take the sales data and add this as a transformation. You'll notice that there's a bunch of ORs that are added here. The reason is the entire transformation is one expression. And we have to do all of these commands, not one after another as multiple commands, but as a single command. And ORs is a simple way of doing that, where you say, look, do this, and that will return a null value. So because it's null and we are saying this or the next value, it'll try running the next command and it'll try running the next command. All of these are going to return null. But it's inserted all of these columns and finally we're going to just return data. So or data will ultimately take data and return it back. So we've achieved a transformation in which we've added 3 new columns. This, by the way, is a nice little handy trick for performing data transformations within the YAML. You could, of course, just have written this as a Python script. You could have said, for example, my calc dot my some add columns of data and put all of this code into a mycalc.py. So mycalc.py, just going to save it, mycalc.py, and within this defined an add columns, def add columns of data. And what that will do is run all of these commands. You don't need the or really. And you don't need this either. And finally, you just return the data. This is exactly the same as doing what I just did in the transform. So you could either have this, or if you don't want to add a new file and are okay with the ORs, then this works fine. That little caret out here tells us that all of this should be a single line in YAML. Now that we've done this, let's take the next thing to do, which is set up the formatting. What we'll do is set up some basic formatting for the table using the sales data. So the rule says take the sales table and in that table put in the data from the sales variable. That's the one that we loaded from sales.csv and then transformed. We also say make sure that everything is vertically aligned to the middle and give it a font size of 11 point. This is largely trial and error. Let's, with this, run SlideSense. What that should do is run SlideSense and give us a table with exactly the same columns that we originally had, which is the first 3 and FY 2017, plus the inserted columns, which is bar 2018, 2017, and one more column called growth. And all of these should be in 11 point because we've specified that as a font size. And all of this should be vertically aligned to the middle, irrespective of whether the original table was vertically aligned to the middle. Let's see if it did that. It just opened PowerPoint a few seconds ago. And yes, we have that. It's kind of not fitting on the screen, but that's okay. We'll just go ahead and sort that out as we go along. So that is sorted out. First, let's adjust the table headers. What we want is the table headers to look like this, bold, aligned to the right. So to do that, we'll copy this. What it has is the names of all of the header rows. So under the table, we add a header row where we say the first column is called name, then indication. Then the next column is aligned to the right, but still called FY 2018. The next column is blank. And then FY 2017 aligned to the right, blank, and growth aligned to the right. Let's see what this does. We'll run SlideSense. That parses grammix.yaml, creates an output.pptx, and the result is, yep, the headers are in bold and the relevant ones are aligned to the right. Good. Let's proceed with this. Now, for all of the columns, the text is fairly straightforward. For many of the columns. So the name column, we just need whatever is the cell's value because, well, the name column literally has whatever it's supposed to have. The indication column already has what it's supposed to have. But FY 2018 isn't quite what we want it to be. And you'll notice a minor difference. It's left aligned, but even from a text perspective, we're missing the commas that we want. So let's start by adding that. Yeah, so name and indication, they are fine. Let's add that. And FY 2018 and 2017, what we're going to do is say align it to the right first of all, and then put in the cell value but formatted with a comma. This uses the standard Python formatting syntax. So it puts in the commas. You can specify precision. So for example, dot 2 will add 2 decimal places, but in this case we just want 0 decimal places. So whether you put that in or not, it's fine. So that should give us the numbers like this. Let's validate that. Precision is not allowed in an integer. Oh, okay. These values are integers. So what we'll do is say I want them formatted as floating point. Hopefully it'll do the conversion by itself. And that gives us the commas for each of these. The text out here is blank. We'll sort that out in just a few seconds. What we want for the bars, when I mean bars, I mean these little blue thingies. What we can do for that is use one of these Unicode characters. This is a character that we can repeat multiple times, and we'll give it a blue color, put it in Arial font, and give it 6 points of font size. Now, why 6 points? Because I just tried out this character by trial and error. Let's reopen output, and I just placed this character and found that if it's in Arial and 6 point and it's in, well, hopefully the right shade of blue, then yeah, it looks exactly like the kind of output that I wanted. Now what I've actually done is put in the same character multiple times. I'm showing you with spaces, but without spaces, this is what it, oops, let's copy from this. This is what it looks like, and I can make the bar look as long as I want. So for 19,936, maybe I'll put in 19 bars and 9 bars here and so on, or round it off to the nearest number. Let's do that. So the rules for the text and the color for the bar columns are as follows. We say, give me a color with accent 1. Accent 1 is literally that blue shade that we just saw. So this is accent 1, this is accent 2, and so on. So that's the accent 1 we want. That's depicted as accent underscore 1. Font name is Arial, font size is 6 point. And we put in a formula here that says take this particular Unicode character and multiply it by the cell value divided by 1000 and take round it down to the nearest integer. So this is going to be 19 bars and this is going to be 9 bars and so on. Now you could have instead said, no, well, look, this is so close to 20,000 that I want to round it to 20. That's fine. You just put in a round, small round, comma, to 0 decimals, that works too. And then you've still got to convert it to an int, but I'm just going to leave it as rounding down and go with that. So let's see what this does. It says output permission denied because I still have this open. Let's rerun it. And with that, we have the format that we want except for growth. Let's now add the growth column. I'm going to copy paste this and run it and see what the output looks like first. Again, I need to have closed the presentation, and then I'm going to come back and explain this formula to you. So you'll see that it's added this as a percentage from the growth column and put in the little triangle. So what the formula says is, first, align the whole thing to the right and put in the cell value with as a percentage, but giving it a 1 decimal point. So that's why it's a 0.5% or a 2.4%. After that, also add in red a down arrow if the cell value is less than 0, or else in green an up arrow, and then close the paragraph element. So that's what gives us the up and down arrows. Finally, let's adjust the widths of these columns. I just figured this out by trial and error. So put in the widths as 1 inch, 2.5 inches, 1 inch, etc. There unfortunately is no auto width adjustment that's possible using the current setup that we have. We could probably do some rounding off and approximations, but in this case, we know the column widths up front and therefore can do it manually. So what we've just done is in this configuration, which you'll see in this YAML file, taken a table of data from sales.csv, used a template and formatted that table pretty extensively to give the kind of design that we really want. That's something that PPTX handler makes possible. And the next time the table changes, you don't really have to change the contents. Just update the CSV file in this raw format. The calculations and the reformatting take care of themselves.